Hello teachers, good evening. Here we go. I'm going to discuss about chemical reactions, types of chemical reactions. Okay, so the first type would be the synthesis or the combination reaction. This type of reaction, actually there are two elements and then they just combine into a compound, okay? Usually, like for example, hydrogen gas reacts with oxygen gas and gives us water, okay? So this one is already in a, what's this? In a balanced form, okay? So we have here, always remember combination is, or synthesis, there are two elements combined together to form a compound, okay? So that's it, that's for synthesis. Next one, the opposite of combination or synthesis is decomposition, wherein a compound, given compound, decomposes into two elements or more, okay? So example of this is what? Like water, my example in synthesis, breaks into, decomposes into hydrogen and oxygen gases, okay? Now, as you can see, when H or hydrogen, oxygen, or iodine, bromine, or what more? Chlorine, I think so. They always bear that too because actually they're all, what's this? We call them diatomic molecules, okay? So there you go. Now, combination is just, they're just opposites with synthesis and or combination reaction. Next one, like hydrogen carbonate, decomposes into water and carbon dioxide. Okay, hydrogen carbonate decomposes into hydrogen or no, water and carbon dioxide. Okay, or dihydrogen oxide plus and carbon dioxide. Okay, so that's decomposition. A compound decomposes into elements. Okay. Next one, or compounds, another compounds. Next one, we have here single replacement. Actually, we have this what we call two types of single replacement. One is, I consider A and B as cation. So we have here cationic, okay? And this one anionic. When I say anionic, those which usually are the what's this? Anions, okay? So when it cations, a cation replaces another cation. Look at this. Cationic single replacement, like A and B, I told you, I considered A and B as cations and X as an ion. Look at that. A is being replaced by B, right? So look at that. So it doesn't matter where it comes first, the element or a compound, okay? Always remember the single replacement, one element and one compound, okay? It doesn't matter their order, what would their order be, okay? So it can also be like B plus AX, like that, okay? So it's okay. Now, cationic because cation B replaces cation A, okay? So we have here AX plus B yields A plus BX, okay? So it's cation because a cation replaces another cation, okay? An example for that would be like copper plus silver nitrate, NO3 yields Ag plus copper nitrate. Yeah, there you go. Okay, so in this case, later on I'll be discussing how this reaction is formed, why NO3 here becomes or is having a subscript of 2. Okay, I'll be discussing those kind of reactions when we do the balancing of the chemical equations. Okay, this is another example. Look at that. Copper replaces cation copper replaces cation silver in the reactant, the products. Okay. Another example would be calcium plus water yields calcium hydroxide plus this hydrogen gas. Okay, there you go. So we say calcium plus water replaces, this was another OH actually. So look at that, H, and then gas, hydrogen gas. Okay, there you go. Next one, we have anionic reaction. This is anionic, when we say anion. Anionic, the anion replaces another anion. So again, doesn't matter which comes first, the element or the compound. Okay, so there you go. X is being replaced by Y. As you can see here in our modal reaction, AX plus Y is equal to AY plus X. Okay, so another anion replaces another anion. Okay, so there you go. We have here example. If you think I'm so fast with my with my discussion, you can just comment below this video if it's so fast or not. and do some suggestions if you have some suggestions. Anyway, next one. Example, Cl plus H2O. Oh, no. NaBr, or sodium bromide, yields, what's this? Sodium chloride plus Br2. Okay, there you go. Next one, look at this. The anion chlorine. Okay, remember that chlorine, I'm going to pose some of those like the diatomic molecules. You must be familiar of those. Chlorine replaces bromine. Okay, so that's why we have here sodium chloride from chlorine plus, or reacts with sodium bromide and gives us or yields sodium chloride plus bromine gas. Okay, there you go. Another example, another type of equation is the double replacement. We say double replacement. We have here the anion and the cations replaces itself. Okay, we just refer this as like the exchange of partners, like AX plus BY that yields AY plus BX. Okay, example here is here, I just gave it here. So we have C3H8 yields some of the chemical reactions I use are already balanced. So we have here okay, there you go. Look at this. The oxygen replaces, actually they don't, what's that? They have this one, the carbon dioxide and the oxygen, and the another produces water, which is H and O. Okay, so there you go. Anyway, in this case, we have just like an exchange of partners. Just remember that. Next one, we have there combustion. What is a combustion? Okay, usually combustion, the general type of chemical equation is always a substance. Okay, substance plus oxygen, always with oxygen, because another term for combustion is burning. Okay, always reacts with oxygen that produces carbon dioxide plus water. Always remember that this is combustion type of reaction. Always a substance, any kind of substance reacts with oxygen that gives us always the carbon dioxide and hydrogen, water. Okay, there you go. I'll be going to present you more with chemical reactions later on. After this, let's try to balance and stuff like that, and why these chemicals or like compounds form into like CO2 and H2O in the products. Okay, from the given reactants.